One of the most difficult concepts that I learned about when I was in introductory geology was Bowen's reaction series. So I want to take a few minutes to talk about that. Really, it just deals with the temperatures at which minerals change from solid to liquid. So if you have a liquid and you're cooling that melt down, it's the order in which those crystals turn to solid. Or if you have a solid, it's the order in which those crystals or minerals melt. So let's take just a moment to look at it. So this is our Bowen's reaction series, and you'll see discrete minerals listed from the top to the bottom on the left-hand side, and this is called the discontinuous series. And then on the right side, we actually have two minerals listed, calcium-rich plagioclase and sodium-rich plagioclase. And this is called the continuous series, and we'll talk about why that is in just a second. But let's go ahead and start on this left-hand side. You'll see that I have high T for high temperature written here, and low T for low temperature written here. And so this describes what happens when you have, let's say, a melt at a really, really high temperature. So really high temperature, everything is in liquid form. And then as you cool that melt down, the first mineral that's going to come out is going to be olivine. The next mineral, as you continue to cool that melt down, is going to be pyroxene, then amphibole or hornblende, biotite, down to potassium feldspar, muscovite, and quartz. So that's the order in which that's going to happen. So you have to get to a relatively low temperature when talking about geologic concepts to get that quartz to crystallize out. Now, if you did this in reverse and you had a really low temperature, so let's say just surface temperature, and your rock is going to be just a solid, obviously, the first mineral, assuming that it's in there, that's going to melt is going to be quartz. So quartz melts first, then muscovite, and then all the way up, and the very last thing to melt would be olivine. So that's how this side of Bowen's reaction series works. And just a way to visualize that, if I have my little rock here, and again, this is going to be a solid rock, and let's say that I've got quartz in it, and I've got some muscovite in it, and I've got some potassium feldspar in it. Okay, so that's all solid. So again, at surface temperature, all solid. The first thing as we started to heat it up to melt would be the quartz. So now that would be in liquid form. The next thing to melt would be our muscovite. And then the last, that up. There we go. And then the last thing to melt is going to be our potassium feldspar. And then if you had that same melt that had those ingredients in it, the first thing as you're cooling it down to come out would be your potassium feldspar, and then your muscovite would form, and then your quartz would form last. And so in this case, we just had the ingredients for these bottom three minerals. So you might not get all minerals in a given rock. You're just going to get a segment of these depending on the composition of your melt. But it does help you with that order of what order does it melt in and what order does it cool in. Now, if we take the right side, which is our continuous series, you'll see we have two end members. Our calcium-rich plagioclase forms at high temperatures from a melt, and our sodium-rich plagioclase forms at low temperatures from a melt. So let me clear our little magma pile here. And so what we would see is if we were at really high temperature and this was a melt, and we started to cool it down, the first thing that would come out would be that plagioclase with the calcium taking up those spots. And so you have calcium plagioclase, calcium plagioclase, calcium plagioclase. Now, as you continue to cool it down, what would happen is you might get to this spot here where you actually get a 50-50 split. So you would be cooling, and eventually you would get these calcium-sodium plagioclases coming out. CNP, CNP to kind of represent that. And if you continue to cool it down to really low temperatures, finally your sodium plagioclases would come out. So our NAP, I'll do another one here, NAP. Now, of course, there are other spots in this because it is a continuous series. So right in here, you might have a 75-25% split between calcium and sodium. And here you would have a 75% sodium and 25% calcium. So it's a continuous series. As it's cooling, it's always getting more and more sodium rich. Now, if we take this solid rock and we were to heat it up, the first thing that's going to be released from the rock, the first thing that's going to melt is going to be this sodium-rich material. So the sodium here would melt and the sodium here would melt. As we continue to raise our temperature, our calcium-sodium mix would melt. And then finally, you just have this melt with some calcium-rich plagioclase solid left in it. And finally, if you got it hot enough, it would melt that final kind of part there. So that calcium-rich plagioclase would finally melt and you would have it all melted. So hopefully that helps explain how this works. You'll see in your text that we add other things about composition in the diagram on the right-hand side that helps you really understand what's forming in each of these areas, but that should give you a pretty good idea of how the diagram as a whole works.